We will have everybody muted during the course of the webinar, and the direction that we'll go is we're going to give an introduction to the In-Situ AquaTroll 600 multi-parameter sonde, talk about the sensor specifications, logging capability, uses of the instrument, introduce some software and telemetry interfaces, as well as some additional water quality probe options that are available, summarize things that we covered in the webinar, and then at the end we will open the webinar up for questions from our attendees. So if you have any questions, please make a note of those. It's likely that we will address them during the presentation today, and we will open things up at the end and have you submit your questions via the questions pane at the bottom of your GoToMeeting window over that should be on the right hand side of your screen. So again, I will be the presenter and moderator today. My name is Steve Comby. I'm with Electronic Data Solutions, and we'll get going with this. Again, appreciate your attendance today, and we'll see if we can do something that will educate you and interest you in some new water quality technology. Today we're going to be introducing the In-Situ AquaTroll 600 multi-parameter sonde platform that's customizable, powerful, and intended primarily to address some of the issues that are inherent in long-term deployments, although the sonde can be used for a variety of applications, including lake and reservoir vertical profiling, spot checking on streams, ponds, or springs, and even groundwater monitoring for pumping wells, as well as in-well monitoring. So we'll be discussing some features and their benefits for these applications. First of all, we'll give you a look at the sonde. The multi-parameter AquaTroll 600 has internal data logging and battery power. It has universal sensor ports that support optical dissolved oxygen, conductivity, pH, ORP, sometimes called redox, turbidity, water level, and there's also a, temperature, and there's also a barometric pressure sensor built into every single one of the probes. There is a LCD display, which is very unique for a submersible multi-parameter probe. This LCD display gives you a visual indicator of whether or not you have all of your sensors connected, what the battery life is, overall functionality, and you can even start and stop logging runs with that LCD display as well. So if you happen to get out to the field and you just have all kinds of problems, or your laptop battery dies, your smartphone gets run over by your truck, and you're left there with nothing but your resources, you can actually start a logging run right through the LCD display. Also has Bluetooth wireless capability, so you can use any Android platform, and we'll define that Android platform needs to be 4.4, requiring Bluetooth 2.0 or higher. So this could be any smartphone, tablet that's running the Android operating system. In the near future, In-Situ will release an iOS version of the ViewSitu software. So any of you Apple users out there with your tablets and smartphones will be accommodated as well. Now, for people that are interfacing the device to a data logger, telemetry, SCADA systems, things like this, the AquaTroll 600 does support SDI-12 protocol and Modbus RS-485 communication. So here's a close-up look of the AquaTroll 600 showing the LCD display, the inbuilt Bluetooth and SDI-12 Modbus. All of the metal components are titanium. The blue portion on the left-hand side is the removable battery cover. So you can just twist that open and install your 2 D-cell batteries in there. Logging at a 15-minute interval with the centralized wiper going, you should expect to see approximately 9 months worth of battery life, although this of course can vary a little bit depending on your batteries and site conditions, specifically temperature. The AquaTroll 600 comes with 16 meg of internal memory. There's also an 8 gig SD card that is included, and you can see that in the picture on the lower left-hand corner, a little U-shaped recess right there. That SD card plugs right in there. Now all of the sensors are locked in place to the central wiper. They also have a retaining screw that you can see right there at the base of it. It's basically just a hex screw, and there is a backup sensor tool. So if you're adding or removing sensors in the field and you don't have a hex screw with you, one of those actually locks into the inside of the battery case. The sensors all have wet mateable connectors, and the sensor ports are all universal. So what this means is that you can add, remove sensors in the field. You don't have to dry them off. You can put them in any one of the sensor ports that are on the unit. Now the double-sided wiper is also removable for those of you that are just doing spot checks, maybe lake and reservoir vertical profiling, pumping groundwater wells that may not need a wiper. Basically, you just purchase a blank sensor stem that slides into the middle port, and that's helpful because all of the surrounding sensors lock into that, providing a really durable flat sensor interface that makes the sensor portions very easy to clean. Here's a close-up look of the individual sensors on the unit. So we'll kind of start at the top with PHORP and work clockwise. Flat face conductivity sensor with platinum electrodes. The pressure sensor, if you choose to purchase one with it, so this is the water level and water pressure sensor, is built into the base of the unit. So that's something that's specified at the time of ordering. Turbidity sensor, you can see, is the next one right there. Optical dissolved oxygen sensor. In-Situ brands their optical dissolved oxygen sensors as RDO, which is just simply an acronym for rugged dissolved oxygen sensor. And of course, this uses their removable optical DO caps. So with any optical dissolved oxygen sensor, at some point the lumiphore or sensing material on your optical dissolved oxygen sensor does need to be replaced. In-Situ makes that very easy. You just simply pop off the old cap, put the new one on. There's a little circuit in there that loads all of the coefficients that are unique to that cap, and it also keeps track of the date of the installation, and you can see that anytime you access the sensor, either through your Android device via Bluetooth or directly through a computer with a USB or serial connection, you can click on that sensor and it'll tell you how many days left of the life that's on that classic cap. Okay, we also include what we call smart sensors, meaning each one of these sensors has the circuitry or a little chip inside of it that keeps track of calibration information and sensor performance. So the individual sensor calibration is retained inside of that specific sensor. So if you calibrate a sensor on one sonde, you can remove that sensor, put it into another sonde, and it'll take its calibrations with it. Kind of a concept that is unique to In-Situ. All of the sensors are individually serialized, and they all have self-diagnostics, so they can look at the measurements that they're making and actually report that information in the data if there's problems with the measurement or with the sensor. As we mentioned, these sensors are designed for long-term stable deployment, so they all have a flat face that's easily wiped and cleanable by the central wiping system. Most of the sensors also have extended sensor ranges, such as dissolved oxygen, and we'll get into these ranges here shortly, but turbidity, conductivity, dissolved oxygen ranges have all been extended to still provide the accuracy that you need but cover a wide range of field conditions. The sensors are all rugged and reliable. As we mentioned, they interlock into the unit and into the central stem, and they're all potted. They're all potted to provide a real rugged sensor. The unit also provides automatic salinity compensation for dissolved oxygen, and all of the sensors are NIST traceable, again an acronym for National Institute of Standards and Testing. Okay, we want to go through each one of the sensors individually and just talk about the specs, use, and measurement of that sensor. In-Situ a few years ago went through great lengths to get EPA approval specifically on the measurement processes and calibration that they're using for their dissolved oxygen sensor. This took a lot of time of submitting data to federal, state, and private labs across the country. Most other manufacturers of optical dissolved oxygen sensors are kind of riding on an interim EPA approval. So to differentiate that, In-Situ went out and got specific approval on their sensors that they're using in all of their optical dissolved oxygen platforms. Optical dissolved oxygen, for those of you that have never used a sensor that has this type of technology, they require minimal maintenance. They typically respond about twice as fast as the old Clark cell type of DO sensor. You remember those, the membrane style sensors. The calibrations last a lot longer, and they don't require any flow or movement of water across the sensor water interface. Those electrochemical sensors, typically called a Clark cell DO sensor, when they made a measurement would actually consume dissolved oxygen at the sensor water interface. So if you didn't have movement of water across that sensor, either from natural means or via a stir, which was quite common, and there were even some companies that tried to rapidly pulse that DO sensor so the sensor had time to replenish that water. Not an issue with optical dissolved oxygen sensors because there is no consumption of DO that happens during the measurement. Now the removable sensor caps on this, In-Situ has those last for 15 months after they're installed. They do have a 3-year shelf life, so if you have a budget and you're acquiring some materials with end of year money, you can buy a few of these and put those on the shelf. And again, the whole reason for doing this is to make sure you have the most accurate data possible. Because of conditions with shining an LED on the back side of that sensing material and then possibly having exposure from UV rays from the sun on the other side, this material on any DO sensor will decay over time. I know some other companies just kind of leave that up to you to determine when you're getting bad measurements and to replace that. We've tried to take a proactive approach and keep track of that for you by having that measure the life of that cap. The range of this optical DO sensor is 0 to 50 milligrams across the entire temperature range. So a very high range reading sensor. Now the conductivity sensor probably has a unique look to those of you that have used multi-parameter probes in the past, where you either have graphite concentric circles that are notched into the sensor or titanium electrodes on a pin. The reason for constructing the sensor this way was so that the centralized wiper could easily clean this flat face conductivity sensor. Now, because we're measuring conductivity, we can also provide all of the derived values that come from conductivity. So you can get actual conductivity, specific conductivity, which is referenced to a known temperature, typically 20 or 25 degrees C, salinity, resistivity, total dissolved solids, and using this information for water density. So a lot of things are happening with that conductivity sensor. So what we're looking at there is a 4-electrode conductivity sensor with platinum plated electrodes. The 2 outer electrodes are what we call drive electrodes. The 2 inner one are our sensing electrodes. And also, as is common with conductivity sensors, the voltage is alternated to reduce polarization of the sensor. The range of the sensor, 0 to 200,000 microsiemens. So we've kind of doubled the range that you'll see on most conductivity sensors, yet still providing a very high degree of accuracy. Turbidity sensor, we're using a nephelometric sensor design that meets ISO 7027 specifications. The range of the sensor is 0 to 4,000 NTU, so we can handle a wide range of turbidity from basically clear turbidity-free water to a lot of gunk going down the stream or in your lake. The sensor is also self-compensating design, so internal electronics actually measure the LED drift that somebody might see over years with not being able to provide the same light intensity coming out of that, and it makes adjustments accordingly. The LED intensity is also temperature compensated, and the sensor has very, very minimal interference from external light exposure, such as the sun. Our PHORP sensor, we've kind of stayed with the same technology that we've had for years of having a rebuildable or refillable reference design. So if you look at the close-up of that sensor right there, the bottom portion of the sensor, and let me grab my highlighting tool right here, draw an arrow to it. The bottom portion of this sensor is a reservoir, so you can use a dime or a flat-bladed screwdriver or knife, and maybe 3 or 4 times a year you can open this up and essentially refill this, which is basically like rebuilding your pH sensor, because all pH sensors have a reference material. It's either a gel or a liquid electrolyte solution inside of that provides a reference for that glass pH bulb that you can see right here. Now, that's a consumable material, so if you don't have the ability to refill that, which you generally don't with a gel-filled matrix, then that sensor is essentially consumable and needs to be replaced over time. With the In-Situ PHORP sensor, easily refillable. It takes just probably a minute at the most. Undo this cap, twist it out of there, tap it with your finger, drain the old electrolyte, pour in the new, and then screw this reservoir cap back in, and you're ready to go. One word of note on this, because I actually was one of 10 beta test sites across the country. We were really lucky to have that. So we personally beta tested one of these sensors, one of these AquaTroll 200 systems for 2 months in a northern Utah river, and I was extremely impressed with this pH sensor. I've never worked with a pH sensor that exhibited so little drift over the course of a 2-month period. In fact, on my 4-week visit halfway through the deployment, I did a check in pH 4, 7, and 10 buffers, and it was within 0.1 pH units after just simply being pulled out of the river on there. So I didn't even bother recalibrating that because that was within the specification of the sensor. So very, very impressed with this sensor. Looks like we also have an opportunity for a poll right here. So I'm going to launch this poll. Basically, this helps us collect some data from our attendees on what their preferences are, so that can drive some of our technology and the way we sell and do things. So let me throw this poll out to everybody. So the poll we're going to launch today is, my water quality monitoring includes, and I kind of like to have you check what your application is. So we'll launch that, and I'll give you just a few seconds. I believe this particular question, you can check as many answers as you want. So if you're a water quality scientist that has a variety of applications, then you might be checking a number of different options there. So let me check my audience view. We'll give you a few seconds to respond to this. Make sure everybody's awake out there. It looks like about 2/3 of you have voted so far. A few more seconds. Okay, in the essence of time, we'll close that poll. And I'm going to share that with everybody so you can compare your response to other colleagues that are on our webinar this morning. So that should be shown for everybody. Looks like we have a large groundwater monitoring group with us this morning. And that's cool to see, and that helps drive my interaction with you too. So I'll, when we get to that point, maybe elaborate a little bit more on the use of this for groundwater monitoring. FYI, also interesting to see that a lot of you are interested in going down well with this, which is interesting. It seems like most of the people I talk with are pumping their groundwater to the surface and running it through a flow-through cell. So thank you for that input, and we'll proceed on. If I can get my slides to advance, that is. Okay, let's talk about pressure sensors within the AquaTroll 600, because essentially if you count the barometric pressure sensor, you can have two of them in there. So barometric pressure standard on all models. I'll talk about the importance of that in a minute. In addition to having that barometric pressure sensor, you can also choose to have an internal water level pressure sensor installed, and you can have your choice of a vented or a non-vented sensor when you're doing that. Our operational ranges for the water level sensor are 0 to 30 feet, 0 to 100, 0 to 250, and 0 to 650 feet. So if anybody has really deep reservoirs or deep groundwater wells that they're going into, we can handle some pretty deep depths and water fluctuations. The piezo-resistive, the sensor in there is piezo-resistive ceramic, so very high quality, durable sensor. Now I want to briefly elaborate on the advantages of having an internal barometric pressure inside of the unit. I think there's 2 or 3 of them that are pretty important. One of them is that it automatically enters the barometric pressure during your dissolved oxygen calibrations. So as you're doing a DO calibration, you basically just start that running. As soon as the sensors have stabilized, it says, hey, I'm getting stable data now. I'm going to just go out and read my internal barometric pressure and use that for the calibration. Now, for some reason you think you have a better barometric pressure sensor, you can use it. So you can input your own barometric pressure data if you like. The other things that the barometric pressure sensor does for you is it provides real-time compensation of your percent saturation of dissolved oxygen sensor readings. So obviously the percent saturation data depends a little bit on the barometric pressure. So we compensate those in real time. So if you're pumping a well, taking a measurement in a lake, your percent saturation readings that you're seeing are compensated in real time for the current barometric pressure sensor. Worthwhile point, because there's a lot of people that don't use an internal sensor, that your percent saturation data will actually be tied to the barometric pressure that was in place at the time of calibration, or if they got to the site, sometimes they give the ability to enter a local barometric pressure at that time. The other thing that the barometric pressure does for you, if you're a person that likes working with a non-vented or absolute type of pressure sensor that's reading total pressure, the barometric pressure sensor in the sonde measures the local barometric pressure and automatically subtracts that or compensates your absolute pressure reading for what the local barometric pressure is at the site. So very useful to have that. Let me just do a quick check here to make sure your screens are keeping up with mine. Looks like they are. So we'll advance along here. We have some very good anti-fouling solutions, both active and passive anti-fouling solutions. The active anti-fouling solution is a centralized wiper that you can see in that picture right there. So if you're somebody that's doing long-term deployments and you really want to prolong those deployments to save time and money and travel expenses, this wiper could really benefit you. So this provides a good protection against sediment, biological and non-biological growth that can build up or accumulate on those sensor faces. So having those flat sensor faces makes those very easy to clean. The wiper has a slip clutch mechanism, so if you're cleaning a sensor, or if you're calibrating it, or if you want to remove a sensor to replace with another one, you can just simply take that sensor and just twist it out of the way with your fingers and not worry about breaking the gear drives on that sensor because of this slip clutch. So the sensor has that slip clutch, it's multi-directional, user serviceable, it's dual-sided and cleans all sensors. Now what I mean by it's dual-sided is you'll see there's actually bristles that wipe the sensor faces, and you'll see some kind of, they'll look like they're sticking off in the air right there. The reason for those is if on your sensor guard, when your sensor guard is in place, there's a protective cap at the end. And if you're using that protective cap, and you could perhaps have algae or sediment building up on the face of that could impact your measurements, or the wiper, it'll actually wipe and clean that off. My preference is to just install it without that protective cap, so any thing just doesn't have the ability to build up on the bottom there. Now, we also have passive anti-fouling solutions where you can get a copper guard, and this will actually inhibit the growth of any biological fouling that may occur, such as algae. The copper guard has the same design as the titanium restrictor that you've seen in some pictures there, and it can be used independently or with the wiper. So you can have one or the other or both anti-fouling solutions in place. Now, how do I interface with the AquaTroll 600? You'll see that there's a variety of ways that we give you to talk to this and get your data off of the instrument. For those of you that like to use a smartphone or a tablet in the field, you can interface with the instrument via Bluetooth to your Android smartphone or tablet, and again, soon to be iOS ready. Now, how that happens is there's a Bluetooth transmitter, which is this blue device right here, that would plug into the top of the sonde via cable. So you would just turn on your Android device running In-Situ's free In-Situ software, and you have full functionality to see real-time readings, calibrate the sonde, download data. Basically anything that you can do with the computer can be done via Bluetooth to your Android device. Now you can also, using the same device, talk Bluetooth to your Windows 7 PC, laptop, or tablet. And I shouldn't have limited that to Windows 7. It can be Windows 7, 8, or 10. So running In-Situ's free In-Situ 5 software on any Windows device, you can talk to that via Bluetooth or via a USB or serial connection, direct connect, or through the top of a non-vented or vented cable connected to the end of this. Now, if you're somebody that can really benefit from remote telemetry solutions, we have some very good stuff to you that we'll get to in just a minute, but you also have a hosted data service on the cloud using cellular telemetry devices and the In-Situ HydroView software. And as I mentioned before, if none of these solutions are working for you, just simply go to the display. There's an accelerometer within the sonde that's just like the accelerometer in your smartphone, that as soon as you twist the sonde up so the sensors are pointing at the ceiling, it automatically turns on the LCD. And by tapping it right here on the side, you can cycle through the menus. So kind of by tilting the sonde, you can bring up different menus, and your way of entering or making a selection is by tapping on this portion of the display right here when you're ready to make a selection. So that's your enter key. Good look at In-Situ 5 software here. So these are some screen captures of what the software would look like running on your laptop or tablet. So simplified user interface. As soon as you plug the sonde in and hit connect, it comes up and shows you live real-time readings on your screen. And then you have some very intuitive icons along the top to set up logging runs, do calibration, maintenance, etc. So you can do live polling and snapshot data. So if you're somebody that's doing a vertical profile on a lake, you can see real-time readings right here, and you can just click a snapshot button at the bottom of the screen anytime you want to log that data. For example, if you're taking a measurement at every meter throughout the reservoir column, as soon as you see the reading stabilize on your screen, just tap that icon or click on it, and it'll log all of that data. So very intuitive, easy to use software. I especially like it for calibrating the instrument because it actually uses pictures and a walkthrough scenario helping you with your calibration. This is a look at some screenshots of the In-Situ software. So this is a free Android app that you can get off of the Google App Store. It's used for site management, so you can GPS and photo tag your sites, so you can leverage your smartphone or tablet capability by taking a picture and having that picture associated with the site. You can also use the GPS within your smartphone or tablet and have your X and Y coordinates associated with that site. You can do live data polling with the mark functionality. So if you're pumping a well, doing a vertical profile, streaming live data, and it's stabilized, you just want to take a snapshot in time, you can just tap on a feature there that will log that. Also allows you to do sensor calibration, set up internal logging runs on the sonde. And what's really cool from this that I like is that from the field, you can send data and reports back to your office via email. So as soon as you're done at a site or done for the day or taking lunch, just email that data back. You get back into your office, see an email there from yourself, click on it, and you'll have Excel files for every site that you hit. Something else that's inherent in the In-Situ AquaTroll sonde is automatic calibration reports. So there's an example of one in the lower right-hand corner right there, that anytime you calibrate a sensor, it automatically generates a calibration report. So if you're somebody that needs to support your data, or you want to keep track of your field technicians and what they're doing, these calibration reports are automatically created and logged on the instrument, so you can download those along with the data. Now we do have a low flow module component for In-Situ. So if you're doing groundwater work and you want to do low flow sampling, this low flow module gives you the ability to put all of your well information in there and creates really nice looking PDF and Excel type reports of your data, showing the water quality data as well as the information at the well site. Now, as we mentioned, there's a lot of technology put into this probe that make it very easy to be foolproof and to minimize things that may happen to you in the field. So we have really long life battery operation. The wet mateable sensor connectors are really important. It's suitable for a wide range of applications, from fresh water to brackish seawater, short-term, long-term tests, use with the flow cell, etc. And I think a lot of people also get some comfort from the data logging capabilities. You have 16 meg of internal memory, and it comes with a removable 8 gig SD card that can be removed and replaced. So it's a quick way to download data if you simply don't want to do a USB or Bluetooth connection in the field. Just pop out that 8 gig SD card, put in another card, and take it back to the office to download your data. Another cool thing that they did with the development and engineering of the probe is they have individually sealed compartments and sensor ports to minimize leaks or the leak paths, potential leak paths within the device. So if a sensor leaks because it's cracked or broken, the instrument won't be destroyed because that'll basically be confined to one area. The LCD status, I think, is really cool. If anybody's ever visited a site is wondering, okay, I'm deploying this, did I remember to start a logging run on it? What was my battery life? Should we have checked that? You can see all of that right on the LCD display without having to do a connection through your smartphone or through a computer. So it'll tell you how much battery life you have left. It'll tell you if a logging run is going on that. So you get to see the overall state of this before you slide it back in the deployment tube or the well. They've even taken this to the point where the battery cover has a sensor inside of it to indicate if the cover is attached correctly. It's kind of interesting to see. So if you're snapping new batteries in there, that LCD will actually tell you that the battery cover is open or not in place, which is pretty cool. The interface to this, either through the Android or the Windows functionality, is very easy to use, so it cuts training time in half. The software leads you right through the calibrations and setup. Another neat thing that they've implemented with the sensors is they have basically calibration solution auto detect. So if you're putting in a conductivity standard or a pH buffer of a known value, it'll look at the millivolt output that the sensor is reading in that and say, hey, this looks like a pH 10 buffer, or it looks like a 1413 conductivity solution. So it can really help people with calibrations doing that. Of course, you can override that if maybe you're temperature compensating your calibrations and it's saying, hey, I'm reading a pH 7 buffer. You can say, oh no, I really want to make this pH 7.15 because I'm temperature compensating that. You have that full capability. You have fast downloads to your computer or smartphone with the USB or Bluetooth communication. So very easy to use. The instrument is also low power consumption, minimal calibration solutions are required. One thing that I want to mention that I just thought was really clever with this when I was using it, and I was kind of drawing on about 26 years of training, selling, and working with multi-parameter sondes. So when you're going to the field with a lot of sondes, you have to have a storage or a calibration cup in place, and then sometimes take a sensor guard out there with you as well. What's pretty novel with the AquaTroll 600 is the titanium sensor guard is reversible. Because of the way the sonde is constructed, that sensor guard can be slid on to act as a calibration cup itself. The sensor has O-rings, right? I clicked and I didn't want to. They have some O-rings right here and further down here, so you can reverse that sensor guard, slide it on so the holes are actually covered up between these two O-rings, and that'll hold the storage solution inside of it. And when you get to the site and you're ready to take some measurements or deploy it, you just simply flip that sensor guard around, put the cap or the plug in the other side, and you're ready to go. So it kind of reduces the number of things you have to take out to the field. Let me get rid of my little highlighter pen so I can advance the slides here. We mentioned the calibration reports that are so important for justifiable and verifiable data, the NIST traceable calibrations, the calibrations across temperature and instrument range. So a lot of things kind of joining together to help you get the best data possible. Now the instrument is also flexible, that if somebody has limited needs and maybe a limited budget, you can buy the thing with just maybe 1 or 2 sensors to start out with, and then add different sensors as you get the money on there until you build up that complete configuration. So makes that very flexible for people with limited budgets and or changing needs. The ability to leverage your Android phone or tablet as a handheld will also save you some money. So you don't have to buy the manufacturer's proprietary handheld that can only be used as a handheld for that instrument. So that can greatly save you money too. Another neat feature for long-term logging is that we have multiple logging modes. So you can set it up to log like every hour, or you can do what we call event logging modes. So if you're maybe doing a stormwater type of monitoring, you can say, okay, I want you to look at the sensors or make a measurement every 5 minutes, but I only want data logged unless X change occurs, and that change can be maybe turbidity going over a threshold of 50 NTUs, or a change in that conductivity reading. And when that condition happens, you can say, okay, I want you to actually log at that 5-minute rate. So that could be a change in water level or a change in one of the other water quality parameters. We have customizable cable lengths. You can order any cable length you want. Cable extenders that if you're already using some in-situ equipment like level trolls and things like this and have existing cables, you can link those together with the cable extenders. And they're making this instrument to be future-proof, so you can add new sensors with only a firmware update. So that makes that very nice and easy as well. Okay, I want to launch our second poll, and we're getting close to the end of this. I apologize if I'm getting a little bit long-winded on some of these things. So for this second poll, we're going to let you weigh in that if you could choose one additional sensor for the AquaTroll 600, in addition to the sensor suite that it already includes, what would that selection be? So I provided what I thought were 5 of the most common ones right there. These would include chlorophyll, total dissolved gas, nitrate, ammonium, or chloride. So if you had to choose one of those 5 for your next, for another sensor for this thing to support, what would that be? So it looks like just a little over half of you voted. We'll give that a few more seconds and then we'll wrap this survey up and share the results. So again, you can see how your colleagues are weighing in on this. And as always, I'm a little bit surprised at the answers there, a little bit, but let me close this voting off and share those results. We didn't get quite as many people voting this time. Maybe that meant they were happy with the things the way they are. Okay, so it looks like nitrate wins out hands down, overwhelmingly, the next sensor option on that. I'll share that with In-Situ engineering. Okay, let's hide that. The thing I want to emphasize on this screen is that In-Situ provides very good technical support. In fact, they have 24/7, 365 days a year technical support. So they trade off. There's always a guy that is carrying a cell phone that has their 1-800 help number on it. So if you're a consultant, you're out there on a weekend or heaven forbid a holiday doing your well testing and you just can't figure something out, there's somebody you can call. Let's get this to advance again. There we go. Told you I would talk about groundwater monitoring with the AquaTroll 600 and then to another extent with another instrument we'll just briefly touch on in the summary. So you can get the AquaTroll 600 with a low flow system. Now it doesn't necessarily have to be a low flow system. You can basically do your purge and sampling through this flow cell as well. So this flow cell attaches to an optional base plate, or there's a spike that screws in the bottom if you're working in a field or a pasture and just want to push it into the ground. You have barbed fittings at the base and at the top of the flow cell, so you can hook your pump tubing into that, run the water through that, discharge out the top, and see real-time readings on your computer or smartphone. What's really cool about using a smartphone or a Bluetooth device, again, this could be a tablet, while you're doing something like a well test, is if it's really nasty weather outside, really cold, really hot, raining, etc., you can have your well test going on and you can be sitting in the comfort of your heated cab of your pickup truck running this thing from 30 feet away and controlling that whole test wirelessly through your Android device. So kind of a neat thing. But anyway, this is what the kit includes, available for purchase or rent, like all of the In-Situ instruments. I wanted to touch on telemetry devices too, because we have some new, more affordable than ever solutions for you that include what we call the tube and the cube. Very aptly named, the tubes are the circular ones, the cubes are the ones that are square. So you have options for attaching multiple sensors. You can see with the cube, I can actually attach 5 in-situ sensors to one telemetry device and have all of that data sent back to your own FTP site or the hosted in-situ network running their HydroView software. And you can also have alarming capabilities too, so you can say something like a condition: if water level goes above or below X, I want to receive a text message or an email telling me that this happened. For people that are working with non-vented sensors, a really cool feature of all of these devices is that there is an optional barometric pressure sensor that can be put in there. So as it's reading your non-gauged or absolute sensor, it will compensate that data for the real-time barometric pressure, log both the uncompensated reading, the current barometric pressure, and the corrected reading, and send all that data back to the HydroView software for you to view and download. Now within this matrix, you'll see that there's two cubes. There's the 300S and the 300R. The S simply means solar. So if you look at the white cube right here, there's a solar panel built into the side of it. So if you stand this on the top of a well casing or a tube, maybe you're in a high snowfall area, you can see that snowfall would not accumulate on this very easily or cover your solar panel. The Tube 300R, which is by far our most popular one, is this stainless steel housing with a diameter that's meant to actually slip inside of a 2-inch well casing. And then you can have either an attached antenna or an antenna on a cable if it's, for example, a big steel housing and you need to get that antenna above it. The 300R has a really long life lithium-ion battery inside of it. So that if you're logging data like every hour and then doing a once-a-day transmit of all of those 24 hours worth of data, that battery in there will last you on the order of about 6 to 7 years. So very long time. Now the same differentiation between the Cube 300S and 300R. You have one with a small 1-watt solar panel built onto the side of it, another one that has the long life lithium battery in it. Now these are very affordable and cost effective. If I look at something like the Tube 300R and combine that with In-Situ's non-vented Rugged Troll 200, you can have a complete water level monitoring system with compensation of the data and telemetry for under $2,000 per site. So very, very cost effective. Prices have really come down with telemetry, and we're happy to bring these options to you. This is a look at the some screen captures from the HydroView data services. So this is a data storage visualization and analysis software tool that runs on the data hosting service. Your data hosting fees are $35 per month per site if paid 12 months in advance, or $40 per month if you're paying monthly. So that includes your cellular transmission. So it's basically like your cell phone bill, but it also includes the data hosting capabilities that you get with HydroView. So you have advanced setup options, connect and log in. You can even create a background map or some aerial imagery and have little thumbtacks showing where your sites are within a watershed or where your well fields are, etc. And then just click on those and see the last transmitted value from that, as well as see a graph or tabular data from whatever time interval you specify. So you could say, I want to see the last month's worth of data of all of maybe 10 water quality parameters at this particular site, and it would bring those up on a window like you see right here. So when you sign up for that, you submit a email address and a username, and you can share that with as many people as you want. So if you're a consultant and you're working with a lot of cooperators on that, and you maybe want to minimize your involvement in disseminating the water quality data, just give them the login information to the HydroView website, and they can just log in and get that data themselves. What I wanted to do now, as we're wrapping things up, is just to do kind of a one-slide overview of all of the in-situ water quality options that are available. So for people that are just looking at temperature and conductivity recording or water level temperature and conductivity, there's the AquaTroll 100 and 200 series. These are sub 1 inch diameter probes, so they can easily fit inside of 1 inch piezometers. And they can just as easily be taken out and used for spot checking as well. All of the in-situ components, I'll take that back, 90% of them I'm going to show you right here, I'll use the same software and cables. There's one or two exceptions to that. Now for those of you that need multi-parameter data, there's the AquaTroll 400. So if you have an existing data logger, SCADA system, telemetry system in place, and you just simply want to collect multi-parameter data, the AquaTroll 400 is an affordable option to get water temperature, conductivity, pH, ORP, depth, and optical dissolved oxygen. So the AquaTroll 400 will output that data via Modbus or via SDI12 to a compatible data logger or RTU on your SCADA system. Now, if you're somebody that's just interested in an inexpensive and reliable spot checking device, groundwater well monitoring system with a flow cell, or doing lake and reservoir vertical profiling, and you don't need turbidity, so that's the key here, you don't need turbidity, then the SmartTroll is probably one of the most cost-effective multi-parameter solutions on the market, especially one that brings optical dissolved oxygen with it. So the parameter suite on the SmartTroll is conductivity, pH, ORP, temperature, optical DO, depth pressure, barometric pressure, and air temperature. Now the SmartTroll was intended to utilize either your iOS device, so your Apple smartphone or your iPad, or any Android smartphone or tablet using Bluetooth 2.0 or higher. So that's how we give you an affordable multi-parameter sonde, is by letting you leverage the capability of your Android or iOS device. And prices that we're talking with this is getting a complete multi-parameter package for under $3,200 with optical DO is really quite a bargain. And really how that's made possible is letting you use your own display. So the Bluetooth device, and it can take different shapes depending on whether it's Android or iOS, is this thing right here. So this is your battery pack. With the iOS device, there's 4 AA batteries in this, either alkaline or rechargeable batteries. There's also a temperature sensor and a barometric pressure sensor inside of this, and just simply has one key. You turn it on or off with an LED light that shows you if it's powered up and if it's communicating or paired to your Bluetooth device. Okay, let's move on. Now, if you're somebody that's just interested in temperature and optical DO measurements, you can use the same cable, the same Bluetooth transmitter, and just simply put on this little tiny titanium temperature and dissolved oxygen sensor, and again, use your Android or iOS device. Now, if long-term monitoring is your thing, either at a factory, wastewater treatment plant, and all you need is temperature and dissolved oxygen data, In-Situ offers the RDO Pro X optical DO sensor transmitter, which you see over on the left. Now you can link that directly to your SCADA system or data logger by itself. It's compatible with SDI12, Modbus RS45, and 4 to 20 milliamp device systems. If you also want a display and keypad, In-Situ offers the Control Pro, which can function as a display, data logger, or transmitter, and output a 4 to 20 milliamp signal to your SCADA system from that device. Want to launch our last poll of the session right now. Help us get some more valuable input from you. This particular question is, my preference for a field display is. So if you would just please take a few minutes out of your time and or a few seconds hopefully, and tell us what your preference for a field display is. We can wrap things up and take some questions from the audience here in just a minute. We have about half of you have voted right now. Give it another few seconds for some people to weigh in. And then we'll close this up and proceed. Looks like we'd better. Looks like we've got all the voters that we want. So we'll close that, share the results. And it looks like kind of tablets are winning the day on this. Thank you for that. Appreciate that. Let me double check, see if you're caught up on the same slides I am. Good. Little GoToMeeting housekeeping. Just lastly, what I wanted to do is just let you know about our company, Electronic Data Solutions. We've been in business going on 30 years. It'll be 30 years next year will be our anniversary. Offer a variety of hardware, software, training, tech support solutions for field data collection. Our home office is in South Central Idaho. We currently have 25 plus employees, 5 field offices. I'm presenting to you today from our field office, which is just outside of Ogden, Utah. In our water resource markets, we offer a variety of instrumentation from leading manufacturers for water level, water quality. We have database software, we have automatic samplers and flow meters, stream gauging instruments, canal and river flow monitoring, flow meters for closed pressurized pipes, and then all kinds of tools for hydrologists, from cup wheel meters, bridge boards, and a whole host of telemetry systems. Now, we also do a lot of work in the global positioning system and geographic information system market, being a leading dealer for Trimble Navigation for their mapping and GIS divisions. We carry accessories such as laser rangefinders from LaserTech. We're an Esri business partner and developer. In fact, we are a gold partner for Esri. And then we also carry rugged field computers. And all of these items are available for rent too. So if you're just doing short-term projects, you need a rugged field computer or tablet or a GPS for your work, pretty much everything that we've discussed and showed to you today can be rented as well as purchased if that fits your project needs better. That's it for today. Thank you very much for attending. It looks like we've had a few people drop off. I probably went a little bit long. My goal was to keep it under an hour. It looks like we're just there. I'm going to open this up briefly for questions. You can stay on just as long as you want, and I'll address your questions. Oh, I probably should have looked at this one earlier, but it's kind of hard to keep track of everything. It looks like we had one user having audio problems at their office. Hope that was just a localized internet thing and that that wasn't widespread. Okay. It's about the only question that we have on there right now. I'll give that a few more minutes for people to submit questions via the GoToMeeting question pane, so I'll read those off and answer those.